Now I'm going to show you how to sketch 3D surfaces. So for example, given this equation, it should yield this elliptical cone. But before we start, I need you to know something by heart. If I give you something like this, then immediately you will know that this is going to be a circle. I need you to know this. And if you have a constant in front of it, it might give you an ellipse. I need you to be able to recognize that. And also, if you get given something like this with a minus y squared equals, let's say 4, it's going to give you something like this. It's going to give you something like this. So because of this minus and in the y direction, you're going to get a gap in between. I need you to know this by heart. And if you get given something like this, y minus x squared equals, let's say 4, I need you to know that this will yield something like this. So because of this minus and in the x direction, you're going to get a gap looking something like this. I need you to know that. I need you to know this by heart. So let's look at this. The idea here is that I'm going to give you a story behind each equation, why it might yield this elliptical cone, and then after a while I will give you lots of examples. So let's try and understand this equation. So z is the height, x here is your x-axis, and this here is, let's say, -1, -2, 1. So this is your positive, and this is your negative. So when you put 0 into here, remember z, as you vary z, you're really varying the height. So for example, you're really varying the height. So you changing z here. Hang on, bear with me. So when you put 0 into this z here, the whole thing here will be 0, giving you something like this. So when you put 0 into the z, it means that you've got a sheet of paper. Imagine this as being your sheet of paper, and it's at a height of 0 because z is 0. So it's, well, when z is 0, looking at this, you can see that x and y must be 0. So when this is 0, x equals 0 and y also equals 0. It has no choice but to be that. That's why you've got 0, 0 here. But when you change z to, let's say, 4, so let's imagine it as this. Bear with me. So you move z up to 4. Let's just say this is 4 here. So keep an eye on this dots here. So let's imagine that to be at level 4. So we're putting the 4 into the z. That will then give us something of the form 16. Forget about this constant. It will preserve the general shape of the surface. So when you put 4 into this z, let's say this is at a level of 4. So now if you look at this, hang on, bear with me. Well, let's ignore these constants because the overall shape will be the same. So when you put 4 into here, let's just imagine it's 16 here, and then you've got something like this. So immediately you can see that this is going to give you a circle. It's going to give you a circle looking like this. If you move the hang on, bear with me. If you put something lower than 4, let's say 3 into the z, it will give you something like this. Let's move it down to a 3 like this. So it will give you, well, if you put a 3 into here, it will be something along the line of 9, and then you've got y, you've got this thing here. So it would be a smaller circle looking something like this. So as you vary, the point is that as you vary the height, you're going to get lots of circles in between, or maybe ellipse in between, as you vary the height. So it's going to give you something like this. So I hope you can see why this will yield this elliptical cone, because as you change the height, you're just going to get lots of circles or ellipse as you change the height. So even if you move in the negative direction, it will give you lots of circles or ellipse. That's why an equation of this form will yield an elliptical cone. In the next video, we will look at this. We will try and understand why this will yield this thing here. Okay, in the next video.